Here this question is asking, in the given circuit, all MOSFETs are identical and they are biased to operate in the saturation mode. Ignoring channel length modulation effect, assuming lambda is equal to 0, the output voltage Vout is what? They are asking for this Vout voltage. Okay, now let's see how we can find it. So first of all, if you look at this, here we have a 1 milliampere current going through this, and you see these are current mirror. How do I say current mirror? Because this is diode connected, so it means this is the I reference. Iref is equal to 1 milliampere, and they have mentioned that all the MOSFETs are identical, which means the width over length ratio is equal. Okay, so usually if I name the current through this as I2, ID2, this is the NMOS. You can see the arrow is pointing outward, so you know that the drain current should be on top, source should be bottom, and this is the gate. And this is I reference, or you can say ID1 as well, and this is ID2. And if you look at the relationship between these two currents, that is basically I reference. If I put this one on top, ID2 over I reference should be equivalent to the width over the length ratio of the both of them. So here ID2 has a width over length ratio, that is W over L2. Okay, and or I can just say W2 over L2 as well. In this way I can reduce one more step. Okay, W2 over L2, W2 over L2, and then I reference has W1 over L1. And since all of them are identical, it means this ratio is equal. Then this over this is equal to 1, which means ID2 is equal to I reference. Okay, so this current must be equal to 1 milliampere as well. Okay, this is equal to 1 milliampere. And there won't be no current flowing through the gate. In MOSFET, there's no current flowing the gate. So it means whatever the current goes here should be the exact current going here as well. So that's one more good thing you can you can know. And if you look at this one, we have 6 voltage right here, and here when the current passes through a resistor, there's going to be a voltage drop. And if you apply Ohm's law, V is equal to I times R. So this one is 4k times 1 milli, and there's going to be a 4 voltage drop right here. It means initially it started with 6. You see this 6 voltage right here. It started with 6, and then there's a voltage drop of 4. Then the voltage right here should be 2 voltage right here. So if this 2 voltage, then that is our VG3. This is gate voltage right here. So VG3 is 2 voltage, and if I take VGS, okay, VG3 is let's mention here because VGS also located here, because VGS we look at this one like this and this. Okay, so VG3 is 2 voltage, then VGS also 2 voltage, because VGS is nothing but VG minus VS, and VS is here grounded, so it means VS is 0, so VG minus 0 is 2 voltage as well. So we can say VGS also 2 voltage. Okay, and this is gonna be helpful because we are gonna use current equation to figure out the output voltage. So let's see how it's related. Okay, this is let's call this one VGS3, because here also we are gonna have VGS. That's one we can call it as VGS4, since this is an M4. Okay, so we have all this information. Now we are interested in output voltage and this one is 6 voltage, so it means whatever the voltage here also 6, and then this gate voltage also 6, so we can say VG4 is 6 voltage, because there's no voltage drop or anything, so it's exact same voltage right here. VG4 is 6 voltage, and for this one VGS, VGS4 is nothing but VG minus VS. So VG4 minus VS4. VG4 we know to be 6 voltage. VS4 we don't know, that is the V out. The source voltage right here, that's the V out. So that's what we are trying to find. We can put VO for this. So VGS4 we don't know. And in a MOSFET, like let's say this current flow through this ID4, that should be the exact current flowing through this one as well, ID3, because in a MOSFET there's no current flow in the gate. So it means whatever the current in the drain is equivalent to the current goes to the source. So this ID4 is equal to ID3. ID4 is equal to ID3, and that one is helpful because if you look at the current equation is given by this. For example, if I write ID4 current equation, you can write it like this: half time Kn VOV square, and VOV is nothing but VGS minus V threshold square. If you write in that way, it will be helpful because we are trying to find out VGS value. If you figure out VGS, we can solve for the VO, because currently we have two unknown variable. If you find out VGS4, then only one unknown variable VO, then we can solve it directly. So instead of V over try, we can write VGS minus V threshold square as well. VGS minus V threshold square, and this is VGS4. And ID3 also same equation. The only difference is here we will have VGS3. The V threshold is equal for everything, and Kn is equal for everything, and the others are equal. So this is half Kn VGS3 minus Vt whole square. And since ID3 is equal to ID4, as we see the relationship here, we can say these two are equal, and you see these two terms cancels, like half Kn cancel. We will end up having VGS4 minus Vt whole square. Whole square is equal to VGS3 minus Vt whole square. And if you square root both sides, then this is going to be VGS4 minus Vt is equal to VGS3 minus Vt. And here we can cancel the Vt also, because if I bring this negativity to the other side, that's positivity, positive, negative cancels each other. So we can just get rid of it. So now we can say VGS4 is equal to VGS3, and VGS3 we already know VGS3. We did it here because we saw the current 1 milliampere flowing through the 4 k ohm resistor. That makes a voltage drop of 4 voltage, and it's initially started with 6 minus 4, we got 2 voltage right here. That was our gate voltage for the VG3, and VGS here is VG minus the V source. V source is 0 because since it's connected to the ground. So VGS3 is also 2 voltage, because VGS3 is nothing but VG3 minus VS3. VS3 is 0, so VG3 must be equal to VGS3, that is 2 voltage. So we already found out the VGS3 right here, that's 2 voltage. So it means VGS4 also 2 voltage, since we found out both of them are equal. So now I have only one unknown variable. So here I can solve for the V out if I bring this equation back. VGS4 is equal to VG4 minus VS4, and we know the VGS4 to be 2 voltage, we know the VG4 to be 6 voltage, and we are just trying to find out the V output. VS4 is the V output, this is the source, and that's where the V out is located. And if I rearrange this equation, then V out becomes 6 minus 2, and that is equal to 4 voltage. And that's our output voltage for this given circuit. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.